Good day. Today I'm going to show you how to deal with general solutions in trigonometry. If you want to learn all the skills of general solutions from the basics to the last level, the grade 11 and the grade 12 playlist is found at the end of this video. Alright, let's start from the very basic level. So we're given 2 sine x is equals to -1. You are told solve for x in the interval. X is an element of 0 until 360. So we have to find all the values of x, and the values must be between 0 and 360. So let's begin. So we are told so far that 2 sine x is equals to -1. So we have to make x the subject of the formula, and the first thing that we can do is to divide both sides by 2. And we're going to end up having sine x is equals to -1/2. And in order to make x the subject of the formula, we have to use inverse sine. So then we're going to have x is equals to inverse sine or arc sine, -1/2. And that is going to give us -30. So we have x as -30. So we call this the reference angle. So we can say a reference angle is -30. So we call this the reference angle. We have to get our general solutions. What are general solutions? What are we talking about? How do we use reference angle in general solutions? Alright, so these are the general solutions for sine and for cos. These are not hard to memorize. All you have to do is to consider which quadrants are the trigonometric ratios positive. For instance, in this case, let's look at sine first. Where is sine positive? Sine is positive in the first and in the second quadrant. So it's positive in the first and in the second quadrant. So all we have to do is just to make it look like the quadrants. For instance, in quadrant 1, the rule is just theta. That is why we just say the reference angle. In quadrant 2, the rule is 180 minus theta. So that is why we said 180 minus reference angle. So the first thing is that you have to make it look like the quadrants. And then the second thing is that you always have to say plus k360, and k is an element of integers. So we have said it here and also here, plus k360, and k is an element of integers. So that is how we write the general solutions. We have to write it in terms of the quadrant in which they are positive. So since sine is positive in the first and in the second quadrant, we make it look like the first quadrant and the second quadrant. And we have to say plus k360, and k is an element of integers. Let's look at the one for cos. So where is cos positive? Cos is positive in the first quadrant and in the fourth quadrant. So the rule of the first quadrant is just theta, so we just say plus reference angle. And the rule of the fourth quadrant is 360 minus theta, so we say 360 minus reference angle. So it's very simple to create them. That is how we memorize our general solutions. So the general solutions for tan is a little bit different. Instead of saying 360, we will now say k180. So every time we're writing the general solutions for tan, we have to say plus k180. So let's consider where is tan positive. Tan is positive in the first quadrant and in the third quadrant. So in the third quadrant is 180 plus theta. So in the first quadrant, the rule is just theta. That is why we say reference angle. And in the third quadrant, the rule is 180 plus theta. That is why we say 180 plus reference angle. So just remember, when it comes to tan, we say k180. So given this understanding, let's proceed to using the general solutions according to the examples. Remember, we found our reference angle by solving for x. So we were given 2 sine x is equals to -1. So we had to make x the subject of the formula. And when we made it a subject of the formula by using inverse sine, we ended up getting -30. So therefore, our reference angle is -30. So what do you do? Remember, this is sine. So we have been dealing with sine. So therefore, we have to use the general solutions for sine. So since sine is positive in the first quadrant, we're going to say the rule of the first quadrant is reference angle plus k360. And we'll say k is an element of integers. Now we can substitute the reference angle, which is -30, into the formula. So then it's going to be x is equals to -30 plus k360, and k is an element of integers. Each trigonometric ratio will always be positive in 2 quadrants. So we've just found the first equation. Let's find the second equation. So sine is also positive in the second quadrant. So in the second quadrant is 180 minus theta. So we're going to say 180 minus reference angle plus k360. and k is an element of integers. So let's proceed. So our reference angle was negative 30, so it's going to be 180 minus, here you have to be careful, it was negative 30, so now we'll have a double negative. So let's proceed. This is going to be plus k360, and then from here we're going to say 180 plus 30, so this just becomes 180 plus 30. So then this becomes k360, and then from here this is gonna be 210 plus k360, so k360, and k is an element of integers. And there we have it. We have got our second equation, so our first equation and our second equation, and there we have it. So now we can proceed to finding x. So these are our two general solutions as we found them. So if the question says find general solutions, we stop here because we have found our two general solutions. But if the question says solve for x in the interval 0 to 360 as it was given in the question, in this particular case, they said solve for x in the interval 0 is to 360. We have to substitute values in place of k, and we have to see what answer it gives us. And we have to make sure we only write down answers that are within this restriction. For instance, in this case, we'll start by substituting 0 in the first equation. So if we substitute 0, we're going to end up having minus 30 plus 0 times 360. So it's obvious that the 0 makes the 360 disappear, and our answer will be negative 30. So let's find out, is negative 30 within the restriction? Well, it's not within the restriction. It's lower than 0. They said it must be from 0 to 360, so we're not going to write it down. So what about 1? If we substitute 1, we're going to end up having negative 30 plus 1. So we're going to have negative 30 plus 1 times 360. And this part 1 times 360 is just 360. So we're going to have negative 30 plus 360. And negative 30 plus 360 is 330. And 330 is within the restriction because it's greater than 0 and it's lower than 360. So it must be from 0 to 360. So in this case, it's between 0 and 360. So it works. So we're going to have 330. So we are allowed to write down 330. And matter of fact, you don't really need to do the working out as I'm doing here. All you need to do is just to type this in the calculator, and the answer that it gives you, you have to check if it's within the restriction. If it's not within the restriction, you ignore it. Then you change the substitution number. So 1 works. What about 2? So if we substitute 2 in place of k, we're going to end up having 2 times 360. It's obvious that it's not going to work, but let's just check. So we're going to have 720, and 720 minus 30 is 690. So it's way above the restriction. They said it must be from 0 to 360, so it doesn't work. If 2 does not work, we don't even have to bother checking 3 and stuff. We know it will definitely not work. Alright, so we have checked 0, we have checked 1, and we have also checked 2, so obviously it doesn't work. So from 2 going onwards, it will not work. Alright, now we have to check negative 1. So let's check negative 1. So if we check negative 1, we're going to end up having negative 1 times 360. So it's obvious that it's not going to work. So it's going to be negative 30 minus 360. So this will give us negative 390, which is way below the restriction. They say it must be from 0 to 360. And if negative 1 does not work, we don't even have to bother checking negative 2. So negative 2 will obviously not work. So we're done with the first equation. So now let's check our second equation. So in our second equation, if we substitute 0, we are obviously going to have 210 because 0 times 360 just disappears. So we're going to have 210. So we're allowed to write 210, and remember from the first equation what worked was 330, so we were allowed to write it because it was part of the restriction. When we substituted 1 in place of k, we ended up having 330 as the result of this stuff. So in the first equation, 330 was what worked, so we're allowed to write this 2 down because they're within the restriction. So what about if I put 1 in place of k? It's obvious that it's going to be way above the restriction because 1 times 360 is 360. So we'll end up having 210 plus 360, which will be definitely above the restriction. So we'll have 210 plus 360, and this is just going to be 570. It's way above the restriction, so it's not going to work. So we tested 0, 0 gave us 210. We tested 1, it was above the restriction, so we don't even have to bother testing 2. We don't even have to test 2. So let's test negative 1. What about negative 1? So if I put negative 1 in place of k, we'll end up having 210 minus 360. and 210 minus 360 will end up giving us negative 150. So it's way below the restriction, so it's not going to work. So the only answers that work is 210 and 330. Matter of fact, in this type of questions, whenever they give you an interval and they say solve for x, it's most likely that you're going to have either 2 answers or 4 answers. In most of the question, that is the case. So if the restriction is 0 to 360, you are more likely to have 2 answers. If the restriction is from minus 360 to 360, you are more likely to get 4 answers. So that's how it is. So our answers are x is equals to 210 and x is equals to 330. So those are our answers. In this case, we've got 2 answers. Alright, here is another example. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, here is another example. So you're given 2 cos x minus 22 is equals to negative 1. So this is a little bit different. First, we'll just divide both sides by 2, and we're going to end up having cos x minus 22 is equals to negative half. And then from here, we'll obviously, in order to make this the subject of the formula, we're going to have to use inverse cos. So we're going to have inverse cos is equals to negative half. And then from here, we're going to have x minus 22 is equals to, so inverse cos negative half should be 60, negative 60. So we're going to get negative 60. So if you type it in the calculator, you're definitely going to get negative 60. And then from here, please do not transpose this to the other side of the equation. If you transpose it to the other side of the equation before putting it into the general solutions, you'll get it wrong. So every time we have something like this, we do not have to transpose anything to either side of the equations. We have to first put it into the general solutions. Then from there we can solve. So in this case, we are dealing with cos. So where is cos positive? Cos is positive in the first quadrant, so it's reference angle plus k 360. And k is an element of integers. So we're going to end up having, so what is on the left hand side, you will take it as x. And then what is on your right hand side, you will take it as reference angle. So we deal with things a little bit different here. Whenever you've got this type of situation, you take what is at your left hand side as though it's x, and what is at your right hand side as though it's the reference angle. So since it's positive in the first quadrant, it's just reference angle. So it's going to be reference angle plus k 360. And we know that k is an element of integers. So from here, now we can solve. So then we're going to end up having x is equals to minus 60 plus 22 plus k 360. And then from here, we're going to end up having x is equals to, so minus 60 plus 22 should be minus 38. So we're going to have minus 38 plus k 360. And k is an element of integers. So this is just our first equation. Let's get the second one. So cos is also positive in the fourth quadrant. And in the fourth quadrant, is x is equals to 360 minus the reference angle. And then we're going to have plus k 360. And k is an element of integers. So we take what is at our left hand side of the equation as though it is x, and what is on our right hand side of the equation as though it's the reference angle. So x in this case will just be x minus 22, and then we're going to have 360 minus our reference angle, which was negative 60. So in this case, we're going to have double negative. So we're going to have minus 3, so minus 60. So then we're going to have k 360. And then from there, so we know that k is an element of integers. And then from here, we're going to end up having x minus 22 is equals to 360 plus 60 plus k 360. And then now we're going to have x is equals to, so 360 plus 60 is 420. 420, so we'll have 420 plus 22. So it's going to be plus 22 plus k 360. And then from here, we're going to have x is equals to 442 plus k 360, and k is an element of integers. So there we have it. These are our two general solutions. So we've got the second equation and we've got the first equation. Any questions you've got, please comment below. So because the question didn't say solve for x, they just said find general solutions, we stop here. Alright, here is the third situation. So here, do not get confused. You just have to deal with numbers on one side and letters on the other side. So this is just letters, meaning that it remains on one side. Now these are just pure numbers, meaning that they both have to be on the other side of the equation. So we're going to have cos x is equals to sine 17. And when you take this part to the other side of the equation, you're going to have minus cos 71. So that was just a trick. Whenever you see this kind of stuff, you just have to put pure numbers on one side of the equation, because these are pure numbers, and then letters on one side of the equation. So do not get confused by the situations. These are pure numbers. Just like if you have cos x, let's say plus 2 is equals to 4, and let's say here you've got 5. You would actually take this to the other side so that it can be 5 cos x is equals to 4 minus 2. So letters on one side, numbers on the other side. So then you just have 5 cos x is equals to 2, and then from there you would divide. So then you'll end up having 2 over 5. So you'll end up having cos x is equals to 2 over 5. So the same way you deal with this situation is exactly how you deal with this situation. So these are just pure numbers. Do not get confused by them. They do not have x. They are not variables. So do not get confused by this stuff. Whenever you see this stuff, these are pure numbers. They don't have variables. They're just pure numbers. So you have to just keep letters on one side of the equation, and you have to take numbers to the other side of the equation. So then this is just going to be sine 17 minus cos 71. So you deal with this exactly as how you would deal with this. Whenever you would have 5 cos x, for instance, let's just say you've got 5 cos x, let's say plus 2 is equals to 4. What you would do is that you would make sure that numbers are on the other side of the equation, while variables are on one side of the equation. So for instance, you take 2 to the other side so that it's going to become 5 cos x is equals to 4 minus 2. And then from here, you'll end up having 5 cos x is equals to 2. And then from here, when you divide both sides, you'll end up having cos x is equals to 2 over 5. So the same way we kept letters on one side and numbers on the other side of the equation is exactly how we deal with these things. So with these things, pure numbers must be on the other side of the equation, while letters must be on one side of the equation. So in this case, we've got letters on one side and pure numbers on the other side of the equation. So from here, now we can just type this in a calculator. So this is going to be So from here we can type this in the calculator and leave it in decimal places. Or if you want, you can actually say inverse cos. You can actually say inverse cos, because in order to make x the subject of formula, we have to use inverse cos. So you can say inverse cos, this stuff. And then you'll have cos 71. And it will still give you the answer. So you can type it like this, or you can get this first in decimal places and then use inverse cos later. So if we choose to instead write this in decimal places and take inverse and say inverse cos later, we'll end up having minus 0.0331964479. So this is what you're going to have. Then from there, you can use inverse cos. So then you can say x is equals to inverse cos or arc cos. So inverse cos, this stuff. So it's just the same stuff. So 0.331964479. So let's find out what is our reference angle. So your reference angle will be 91,90, which is just the same as 91,9. So that's your reference angle. So from there, we have got reference angle is equals to 91,90. And then from here, since we're dealing with cos, we know cos is positive in the first quadrant and in the fourth quadrant. So x is equals to reference angle plus k 360, and k is an element of integers. So from here, we're going to end up having x is equals to our reference angle, which was 91.90. So 91, okay, 91. So we're going to have 91.90, which is just 91.9 plus k360, and k is an element of integers. And there we have it, our first equation. So let's get our second equation. So it's also positive in the fourth quadrant. So it's going to be 360 minus reference angle plus k360. K is an element of integers. And then from here, we're going to end up having x is equals to 360. So it's going to be 360 minus our reference angle, which is 91.9 plus k360. And we know that k is an element of integers. So from here, we're going to have x is equals to 268.1. So 268.1 plus k360. So that is what we have. K is an element of integers. And there we have it, our second equation. So because the question just says find general solutions, we stop here. Alright, here is another example. So in this case, we're given 3 tan x plus sine 27 is equals to 3. So here is another example. So in this case, we're given 3 tan x plus sine 27 is equals to 3. So we do things as usual. Pure numbers on the other side of the equation, and then letters on one side of the equation. So we're going to say 3 tan x is equals to, okay fine, it has to be x there, is equals to 3 minus sine 27. So we're going to have minus sine 27, and then we have to divide both sides by 3 in order to make tan the subject. So we're going to have tan x is equals to, so if you divide 3 by 3, you're going to end up having 1. So it's just going to be 1 minus sine 27 over 3. Or if you want, you can just put it in this way. You can just say 3 minus sine 27 all over 3. So that's what you get when you divide both sides by 3. And then let's figure out what is this thing in the calculator. So this is what you're going to get when you use the calculator. So we're going to have tan x is equals to that. And then now we have to make x the subject of the formula. So now we're going to say inverse tan. So inverse tan 0.8486698342. Alright, let's find out what is the answer. So our reference angle will be 40.32. So our reference angle is 40.32 degrees. Alright, so from here we're dealing with tan. So tan is positive in the first and in the third quadrant. So let's do it the first quadrant. So we're going to have reference angle plus. Now we have to be careful. It's not 360, but it's 180. So with tan, it's 180. So we're going to have 180. And then, of course, k is an element of integer. So let's substitute our reference angle. X is equals to 40.32 plus k 180 and k. Alright, so k 180 and k is an element of integers. And there we have it, our first equation. So let's create our second equation. So now we know it's also positive in the third quadrant. In the third quadrant is 180 plus reference angle plus k. Now instead of 360, it's 180. K is an element of integers. So from here, we're going to end up having x is equals to 180. Our reference angle was 40.32. So 40.32 plus k 180. K is an element of integers. And then from here, we have x is equals to 220.32 plus k 180. K is an element of integers. And there we have it. These are our two general solutions. Alright, here is the final example. So we're given 4 sine x plus 64 is equals to 3 sine 64. And in this case, we see that numbers on one side, variable on the other side. Of course, we have to deal with this 4. So when we divide both sides, we're going to end up having, so when we divide both sides by 4, we're going to end up having sine x plus 64 is equals to 3 over 4 sine 64. So let's figure out what is this in the calculator. Alright, so this is what we're going to have in the calculator. So we're going to have sine x plus 64 is equals to this stuff. And then now we have to make x plus 64 the subject of the formula. So in order to make x plus 64 the subject of the formula, we're going to use inverse sine. So we're going to have 0.67409553,742. So let's figure out what is done in the calculator. So we're going to end up having 42.38. So when we get to this part, remember we take this stuff as though it is x and we take this stuff as though it's our reference angle. We are not allowed to transpose 64 to the other side of the equation before putting this stuff into the general solution. If we do that, we'll end up getting our answer wrong. So we have to put this stuff into the general formula first before we even take anything to either side of the equation. So since we're dealing with sine, we know that sine is positive in the first quadrant and in the second quadrant. So in the first quadrant is reference angle plus k 360, and k is an element of integers. And then from here we'll have, so now we take this stuff as x, so we'll have x plus 64 is equals to, this is our reference angle, so it's going to be 42.38 plus k 360, and k is an element of integers. So from here we're going to end up having x is equals to 42.38 minus 64 plus k 360. We'll end up having minus 21.62. So plus k 360, and k is an element of integers. And there we have it. We've got our first equation. Now we need to get the second one. So we know it's also positive in the second quadrant. And in the second quadrant is 180 minus reference angle 180 minus theta. So plus k 360, and k is an element of integers. So we take this as though it is x. So therefore we're going to end up having x plus 64 is equals to 180 minus, and our reference angle in this case is 42.38. So we're going to end up having 180 minus 42.38 plus k 360. K is an element of integers. And then from here we're going to end up having 180 plus 64 is equals to 180 minus 42.38. We'll end up having 137.62 plus k 360. And then from here, when we go forward, we're going to end up having x is equals to 137.62 minus 64 plus k 360. And then from here, we'll end up having 73.62 plus k 360. And there we have it. We have got our second equation. So our first equation and our second equation. So if they say solve for x, we have to proceed and substitute values like 0, 1, and 2 in place of k and get our values that fit the restriction. But if they say find the general solutions, all we have to do is just to get the general solutions and we're done. And these are the general solutions. So k is an element of integers. Let's just not forget that part. Alright, this brings us to the end of this video. If you enjoyed this video, please like the video and subscribe to my channel. And also support me by sharing the video. Any questions you've got, please comment below. And if the numbers I've provided in the advertisements are not working, please comment below.